Good evening. Yes, Shashwata, good evening. So, this is the first class of categorical data analysis. Okay, so first I define what do you mean by categorical variable. The categorical variable. Yes, Pritam, good evening. Pritam, are you hear me? Can you, am I audible? Please tell me. Yes, Sharnabho, good evening. Am I audible? Please tell me. So, categorical variable. Okay, thank you, Sharnabho. A variable which takes values on a scale consisting of some categories is called categorical variable. For example, a variable named political ideology is a categorical variable. Because it takes values on scale consisting of several categories. Namely, liberal, moderated, moderate, and conservative. And any data collected on a categorical variable is called categorical data. Categorical variable have two primary types. One is nominal and another is ordinal. So have two primary types. Categorical variable have two primary types of scale. One is nominal scale and another is ordinal scale. Nominal scale means here we cannot order. That means for example, I think it is better to give example for nominal variable. Example, say religion. Religious affiliation, and it has categories are it has a categories, that is Hindu, Muslim, Catholic, Protestant, Jewish, and other. And the order, here we see that the order of listing of the category is irrelevant. Okay, so the nominal data means when the categorical data which we cannot order, okay, or ordering is meaningless. This is called nominal. And ordinal means, for example, social class, suppose social class, and we classify these as upper, middle, lower. So here we see that we can order the category so such type of variables is called ordinal variable. Okay, another example, for example, patient condition. good, fair, serious. So here we also see that these categories can be ordered. Okay, so this type of variable is called ordinal variable. Okay, so please give me some example. Nominal and ordinal, except this. Prashot, Pritam, Tornabo, Orko, please give some example. Please write in the comment section. First, you give nominal, except this religious affiliation. So, construct the example. It consists some categories which we cannot order. Okay, or order is irrelevant. So, please give me some example, except this. So, please tell me. Shashwat, Pritam, blood group, okay, is a nominal. Good. Pritam gives example, blood group. Okay, very good. So another example, blood group. Blood group, caste. Caste already I already consider Swarnabho. That is a religious affiliation. Or yes, you may consider caste also. Okay, thank you. Caste. Caste. Okay. So hair color, very good orthoproof. Hair color is also a nominal data or nominal variable. Okay, so these are the nominal. Okay, so I think you can understand there are several examples. Blood group is, this is also blood group means A, B, AB, O. This type of these four categories, but you cannot order this category. Okay, or even if you can write AB or BA, OB, both are same things. Okay, so because here order is irrelevant. Caste also same thing. This is also a nominal variable. Hair color black, brown. These are the hair color. So this is again a nominal data. Okay. So please give me some example except these two ordinal variable. Give some example of ordinal variable except these two. Please also put right. Karnabho, Pritam, Shayok, please tell me. Please tell me some example. Except these two. Please tell me. So here you give example, construct the example where ordering is possible. Okay, ordering is possible. So please provide some example except these two. Keep in mind that order is possible. One thing you note that for nominal data, you only construct frequency table. Okay, you cannot compute mean, median, mode. Okay, educations like graduation, PG. Okay, thank you. This is also a ordinal. Thank you, Sharnabo. Education, education, not like education. Categories are uh, 10, 10 plus 2, UG, PG, PhD, etc. Very good. Next, also propose rating of movies. Rating of movies. Uh, rating of movies 1 to 5. Okay, this is also rating of movies. Is it a so please tell me, or 1 means what and 5 means what? I think it is better write rating of movies by uh, poor, medium, and good. That or please define 1, 2, 3, 4, 5. Okay, rating of movie. So it is also a categorical. It is also ordinal variable rating of movies movie. Okay, Pritam economical status. Very good. Economical status is another example. Economical status, same thing, social class. Okay, so please tell me another example, Pritam. No, it is different. Thank you. So socio and economic, social and economical class are different. So economical status is another example of ordinal data. Okay, thank you. So autoproof rating of movie, it do not gives like poor, medium, and good. Okay, in that way you can define give the different categories. Okay, I think it is better autoproof rating of movies: worst, first one, bad, good, very good, excellent, very good. So now it is okay. Thank you. So these are the example of ordinal variable. Okay, so now next point is attribute. When the character, here the character observed is not expressible, yes, Shashwat, it is also, if you consider grade, then it is also a ordinal data. Okay, this is also ordinal data. Thank you. So the character observed is not expressible in numerical term. Such character is called qualitative character or an attribute. For example, when we record the sex of each newborn, baby, during a month, or the language of each book in a library the data are not numbers initial. So these are attributes. Okay. So, but for example, the number of books written in English, the number of but but here we get a number. We mentioned this point also. We get a number. We get numbers of female babies for the first example, and male babies and for the second example we get a number of books written in English. The number of books written in Bengali, etc. So first, initially, we see that when we record the sex of each newborn baby, so these data are not numbered numerically, but after that, we get number of female babies and male babies. So we can represent this after collecting initially the data. We can number this data as number of female babies and number of male babies. So this type of data is a attribute. This is a qualitative character. And when for the second example, initially we get the language of each book in the library. So initially this is not a language of each book in the library is not a numerical. We cannot represent this numerically, but after collecting this, we can find number of books in Hindi, in English or Bengali, etc. These are, we can represent this after collecting this data. We can represent these in numerically. Okay, so this type of data is called attribute or qualitative data. Okay, so next thing, dichotomy a classification of the simple kind considered in which each class is divided into two subclasses. And no more has been termed by logician classification, or to use the more strictly applicable term, division by dichotomy. So some notation. We denote the several attributes by capital letters A, B, C, etc. The two form, suppose I consider attribute A, the two forms of A may be denoted by capital A, the positive form, indicating the presence of the character A, and alpha the negative form, indicating the absence of character A. Similarly, for B, when B is present, then we denote by capital B. When it is absent, we denote by beta. For C, for attribute C, if it is present, then we denote by capital C, and if it is absent, we denote it by gamma, and so on. So, suppose the combination AB, so it is better to write in that way, in case of combination of attributes such as AB represents the combination represent represent the both characters A and B present, both attributes A, B are present. Similarly, A beta means A present but B absent. Alpha beta, this means both AB are absent. Alpha B, A absent, B present, and so on. So this is so another example. Suppose if I consider three attributes A, B, C, A, B, C, in that case, A, B gamma indicates A, B both present but C absent. So I think in that way we can denote this. So for class frequency, the number of observations assigned to any class is termed as the class frequency. Class frequency will be denoted by putting the cross symbols within parentheses. So for two attributes, the class frequencies of different orders are order 0, that is capital N, total number of observations. This stands for the class frequency of the class A. First order, this is denoted as, this means total number of frequency when A is present. This means B is present, and this means A is absent, and this means B is absent. And second order, this means A and B both present, A present, B absent, total frequency. And this. So any class so any class frequency can always be expressed in terms of frequencies of higher order classes. For example, this is the first order frequency, that means total number of the class frequency of the class A, that means attribute A is present. This is nothing but A present, B present, both present. This is the second order frequency, and A present, B absent. Similarly, for second order AB, if you consider three attributes, so this can be written as all three are present, AB present, but C absent. So in that way you can present this thing. So now ultimate class frequency a class frequency a class of highest order is known as ultimate class. And its frequency called ultimate class frequency. Yes, Pritam. Please wait. I will provide this. Okay. Yes, you are absolutely correct. Every class frequency can be analyzed into higher frequencies, and the process needs to stop only when we have reached the frequency of the highest order. So, for example, if we have three attributes, say A, B, C, then the first order frequency for A is, first I break it into second order A, B, and where A both present, A, B both present, and second one is A present, B absent. Now I break this into two parts, where because we have a three attributes, both all three are present, A, B present, but C absent. Again, I break into this into two parts. A present, B absent, C present, A present, B absent, C also absent. So in that way, we can express this as a highest order. Okay, Pritam, I think you got your answer now. So you asked me, sir, in the case of A, can we express them as order 3 also? So you see that we express A as a sum of frequency of the order 3, sum of the frequency of order 3. Okay. So Pritam, please tell me, are you, this is your answer? Okay. So please tell me, are you understand or not? So now the total number of cross frequencies. Thank you. Thank you, Pritam. The total number of, even if, Pritam, one more thing, if you have a 4 attributes, say A, B, C, D, if you have a 4 attributes A, B, C, D, then you can again partition this. This is look like a T diagram, okay? Partition this, and all 4 are present, or ABC present, D absent. I denote this by delta. Now AB gamma D, AB gamma delta, then A beta C D, then A beta C delta, plus A beta gamma D plus A B gamma delta. So this is the, if you have a 4 attributes, you can represent a frequency of A, first order frequency, as a sum of the frequencies of 4th order. Okay, clear? And in that way we can represent, if you have a 5 attributes, again you can break this, 6 attributes, again you can break this, and so on. This is the process. So now the total number of cross frequencies order 0, here I consider only 3 attributes. Okay, more than 3 attributes we can easily generalize this. This is the process. So ordered 0, total frequency in, order 1, this is break into 6 part. First, these are the present, and these are the absent. Again, order 2, alpha C, beta C. Okay, and this is alpha beta, alpha gamma, beta gamma, and order 3 it is ABC, AB gamma, A beta gamma, sorry, A beta C, A beta gamma, and alpha BC, alpha B gamma, alpha BC, alpha B gamma. So this is for order 3, this is for A. So these are the order 3, okay, these are the order 2, and this is order 1, and this is order 0. So if you have a 3 attributes, we can partition this out. So thus we have three cube distinct class frequency in all. So my question is, suppose we have n attributes, small n attributes. So then tell me total number of class frequency. Please tell me total number of class frequency. Total number of class frequencies. Okay, please tell me. Please do it quickly and tell me. Instead of 3, suppose we have n attribute, then tell me the total number of class frequency. So please tell me. So here is the idea. Please see that structure and use this structure. Please tell me. First, tell me the ordered 0. How many classes? Ordered 0. How many classes? Ordered 0. How many classes? Order 1. Order 0. Please tell me the total number of order 1. How many classes are there? How tell me n to the power n? Why? If you according to you, is it fine? If you use 3, n is 3, then it is 3 cube. But if n is 4, that means this is 4 to the power 4. Please tell me how do we how you get this thing. This is wrong. This is absolutely wrong. Please do not use this thing. See the process and tell me one by one. For first, order 0, then find order 1, then find order 2, then find order 3. And add all this, then tell me the value. Okay. See, for order 0, there is a single class, that is n, and this is true for all any number of attributes, so it should be 1. For order 1, you see that first you choose any attributes. How many way? That is 3C1. For particular attributes, there are 2 choices, that is present or absent. Please follow the process. Okay, either present or absent. For here A, attributes A present or absent. This is also true for any attributes. So you can choose any attributes. In here it is 3C1, and each attributes you have a 2 choices. So that is 3C1 into 2. Similarly, for this order 2, you have 3 attributes. Among 3, you choose any 2 in 3C2 OS. Now you see that these 2 attributes have 4 possible choices, because both are present, one absent, and both are absent. So you have a such number of choices. Similarly, for 3, you choose 3C3, and each have 2 Q possibilities. Okay. So in that way, so total number of cases, I write these single things 3C0 into 2 0. So total number of cases here is 3C0 2 0 plus 3C1 2 3C2 2 square 3C3 2 cube. So this is 1 plus 2 whole cube. So this is 3 cube. So similarly, if you have any attributes, so first you choose any one attributes in NC1 OS, and each attributes have 2 possibilities. So it possible in 2 ways. So NC1 into 2. For order 2, you need 2 attributes. So in that case, you choose NC2 such a way, and suppose you choose AB, and for order 2, you have it 4 possibilities, because both are present, both are absent, one present, one absent. So that means 2 square. So many ways. For order 3, this is the total number of possible ways, and so on. So total number of cases here so this is 1 plus 2 whole to the power n, that is equal to 3 to the power n. So clear? Please tell me. Your answer is absolutely wrong. So please tell me, you need more explanation or it is okay? You can please tell me if you have any problem. Tell me. Summation. This is the final. You need to simplify this thing. You know the you know the binomial expansions. And put x is equal to 2, then this is equal to so this is 3 to the power n. Thank you, Pritam. So if you have an n attributes, then total number of class frequencies equal to 3 to the power n. We define n for any attributes. Similarly, now so this means therefore in any symbolic expression you can replace the operators these are called operators a by 1 minus alpha or alpha by 1 minus a. Again, AB equal to this now alpha beta this is equal to alpha beta capital N, use this. Okay, so alpha can be replaced by 1 minus a, so this is, and beta is replaced by 1 minus b. Same way So this is equal to, and this equal to 1 minus b minus a plus ab into n. So again this n bn is nothing but a b, an is nothing but a, abn is this. So therefore alpha beta is equal to similarly alpha beta gamma will show that this equal to this is your homework. Check that. Now condition for consistency. The attributes denoted by capital letter may be termed as positive attributes. I already mentioned this thing. Positive attributes. On the other hand, attributes denoted by Greek letter may be termed as negative attributes. The necessary sufficient condition for the consistency of a set of independent class frequencies is that now ultimate class frequency be negative. If two attributes are noted there are four ultimate frequencies, that is AB both present, A present, B absent, A absent, B present, both absent. Expressing them in terms of positive classes we find the following condition. AB greater than equal to 0, AB greater than equal to A plus B minus N, that is alpha beta greater than equal to 0, AB less than equal to A, this implies A beta greater than equal to 0, AB less than equal to B imply alpha B greater than equal to 0. So these are the conditions. Now for three attributes, the 8 ultimate frequencies are not negative. Will be found to lead to the follows. To the following. So first one is ABC, this is greater than equal to 0. Second, ABC greater than equal to AB plus AC minus A. Third, ABC greater than AB plus AC minus B. Fourth, ABC less than equal to ABC greater than equal to AB plus AC minus C Fifth, ABC less than equal to AB. Sixth, ABC less than equal to AC. ABC less than equal to BC. Eighth, ABC less than equal to N minus A minus B minus C plus AB plus BC plus AC. Independence. Two attributes A and B are said to be independent if AB by B equal to A beta within first bracket by beta. This implies AB by B, which is equal to AB plus A beta B plus beta equal to A by N. Similarly, so this implies AB equal to A B N. So this is again written as ABN AN BN. That means if the attributes A and B are independent, the proportion of this means the proportion of ABs in the proportion if the attributes AB are independent, the proportion of AB in the population is equal to the proportion of A's multiplied by the proportion of B's. So this is the fundamental rule. So we can represent this into a table. These are the attributes. Attributes A, B, present, absent, and this is total. A, alpha, this is total. So both present. Both A present, B absent. This is the total. Alpha B, this is alpha beta. This is B, this is beta, and this is alpha. And this is capital N. Okay. So this is the definition of two attributes. This is the definition of when two attributes are independent. So proportion of AB is equal to proportion of A and into proportion of B. So now okay. If there is no sort of relation of any kind between two attributes, A and B, we expect to find the same proportion of A's amongst the B's as amongst the not B's. So now we consider, if suppose A and B are independent, then we consider this if this relation holds good, then the following equations must also hold. That is alpha b, b alpha beta, beta ab b equal to alpha beta alpha and a beta a alpha beta alpha. So now from start AB by B equal to A beta by beta. So this is same as this equal to so this means that is I just use this thing. So this is nothing but a b minus ab, this is nothing but a alpha b by b equal to this is nothing but a alpha beta by beta, so etc. So in that way, so this thing is proved. If this hold, star is hold, automatically we can show this thing. Similarly, you can show using star, we can show this and this. So this is your homework. Please prove these two parts. If the question is if star is satisfied, that is we know if A, B are independent, that means AB by B equal to A beta by beta. Then using this, you prove this thing. AB by B equal to alpha beta by alpha, A beta by A, alpha beta by alpha. So this is your homework. Prove this thing. So now note that if we have a two attributes, they are independent. Then alpha beta are also independent. So that is we need to show that alpha beta is equal to alpha beta by n. and secondly A beta are also independent. That is, we need to show A beta equal to A beta by N. So now proof of 1. Alpha beta we know is equal to N minus A minus B minus plus AB. So this is again written as N minus A minus B plus A B by N, because A B are independent. Since A and B are independent, this is given. Okay, now this is equal to N A minus B by N equal to N minus A. Why? Because so we can write this thing. So now NA into 1 minus Bn, which is equal to N minus A, N minus B by N. So this is nothing but a alpha beta by N. Now proof of 2. A beta by beta. A beta can be written as the AB plus A beta by B plus beta equal to A by N. This implies A beta equal to A beta by N. And the interpretation is the advantages of I denote this by first I denote this by this is denoted by double star. Okay, so the advantages of double star over star is that it gives expression for the second order frequency I think it is better. This is star. Please ignore this thing. I think please wait. Okay. I think you give this is the double star. Okay. The advantages of double star over star is that it gives expression for second order frequency in terms of the frequencies of in terms of the frequencies of the first order. And the total number of observations. See that? So because the star is this AB, this is the second order, we represent this if AB is independent. So this. So AB represented as a product of two first order frequencies divided by total frequency capital N. So this is the double star. Okay. So please tell me if you have any doubt. Otherwise, I will proceed. So please tell me if you have any doubts up to that. Okay. So the criterion of independence may be expressed in yet a third form, that is in terms of second order frequency also. That is AB alpha beta. This is written as A P by capital N is again alpha beta by capital N. So this is simply as A B alpha beta by capital N. So this implies capital N square, sorry. So this is again, I write this thing as alpha B, capital B, A beta. Okay, so this means AB by alpha B equal to A beta alpha beta, or AB A beta equal to alpha beta alpha B beta. So this is, I denote this by small a, and this is small b. Small a may be read as the ratio of A's to alphas amongst the B's is equal to the ratio of A's to alphas amongst betas. And similarly, we can interpret B. Okay. So this is the example question. This is a homework question. Verify whether A and B are independent or not. Where AB, this is equal to 105, alpha B, this is equal to 95, A beta, this is equal to 280, alpha beta is equal to 505. Okay, so please verify whether A and B are independent or not using this criteria. This is your homework. Now we consider association. A and B are said to be positively associated or simply associated if AB greater than AB by N and AB are said to be negatively associated or simply disassociated if AB less than A B by capital B. That is, one speaks of A and B as being associated if they appear together in a number of cases But here, by positive association between A and B, we mean that they appear together in a greater number of cases than is to be expected if they are independent. The circumstances sorry the circumstances in which the association between two attributes sorry is said to be complete can be explained in two cases. We may say that for complete association for all A's, for complete association, all A's must be B's and all B's must be A's. That is, A beta this is equal to 0 and alpha B this is equal to 0. Therefore, we see that A's and B's occur in the population in equal number in equal numbers. Similarly, for case 2, we may adopt a rather wider meaning and say that all A's are B's or all B's are A's according to whether the A's or the B's are in the minority. Similarly, for completely disassociation, when number of A's or B's number of A's or B's sorry, actually I mean to say that for completely disassociation we mean it is better to write in that way. That means AB 0, so this means no A's or B's and alpha beta 0 means no alphas or betas, or more widely as the case when either of this statement is true. Thus, two attributes are completely associated if one of them cannot occur without the other, though the other may occur without one. We define AB naught, this is equal to AB by capital N, the value of AB under the assumptions that the attributes are independent. So similarly, we define alpha beta naught, which means alpha beta by n, alpha b naught, which is equal to alpha b by capital N, a beta not equal to a beta by capital, and delta denotes the excess of AB over AB naught. So we can write the table as so this is equal to AB naught, the excess value plus delta. So since the marginal total is fixed, so it should be minus delta. So since marginal total is fixed, so it should be this. This is alpha, and this is the total number of observations. So it is capital O. So delta equal to AB minus AB naught equal to alpha beta minus alpha beta naught equal to AB naught, A beta naught minus A beta alpha beta naught, alpha B naught minus alpha B. So now note that delta equal to AB minus AB naught, which is equal to AB minus AB naught means A into B by capital N. So therefore delta equal to NAB minus A minus B by capital N. So this is again, after simplification we get this thing. So alpha B. So please check the steps. This is your another homework. Okay, so clearly delta 0, delta greater than 0, this means positive association, and delta less than 0, this means negative association. and this is no association. Hence, no association, that means A and B are independent. A and B are independent. So, from this we can conclude that this delta determines uniquely the departure from independence. But it may be interested to measure, may be of interest to measure the intensity of association. So it is called delta measure for association between two attributes. And where delta equal to AB alpha beta minus A beta by A beta alpha B by capital A. Now, whose coefficient of associations as a measure of intensity of association between two attributes A and B whose give the following measure following coefficient of association denoted by Q, and is Q equal to AB alpha beta minus A beta alpha B by AB alpha beta plus A beta alpha B, and this is equal to N delta AB alpha beta plus A beta alpha B and we see that AB are independent this means delta equal to 0, and which imply Q also 0. And we observe that, note that Q increases as delta increases. And Q is independent of A's and alphas in the data. So this is your homework, please check this. Next, Q is the symmetric measure, and it increases and Q should be lies between, is a symmetric measure and Q lies between -1 to +1. And the proof is so this is the Q, this is the expression of Q. And I denote this X, this is Y. So X plus Y by X minus Y by X plus Y. So X minus Y by X plus Y. Now, where X is equal to A, B, alpha, beta. So this is greater than equal to 0. Y equal to A beta alpha B. This is again greater than equal to 0. Note that Q, this can be written as 1 minus 2y. See that X plus Y minus 2y, X plus Y. Again we write this thing as 2x minus X plus Y by X plus Y. So we write this as 1 minus 2y by X plus Y. So therefore Q less than equal to 1 because Y and X both positive, non-negative. Similarly, I write Q as 2x X plus Y minus 1. So X, Y both are non-negative. So this should be greater than equal to -1. Combining these two, we see that Q lies between +1 to -1. So Q equal to 1, this means Q equal to 1 means Y should be 0. Y 0 means this part should be 0, A beta alpha B, this is equal to 0. So we know AB equal to 0 means either A0 or B0. So this implies A beta equal to 0 or alpha b equal to 0. So this implies A b equal to A or A b equal to B. So this means A and B are in completely associated. Similarly, we can show that Q equal to -1 if and only if A and B are completely disassociated. We are in completely disassociation. So please prove same way. This is your another homework. So now the last measure for today class, I'm going to discuss this. This is a Wool coefficient of colligation. And this is defined as this is alpha beta, okay, by 1 plus same thing. So this can be written as AB alpha beta minus A beta alpha b, and same thing AB alpha beta plus root over A beta alpha b and this is your homework. Prove that Q equal to 2y 1 plus y square. Q is a Wool coefficient and y is a Wool's coefficient of colligations. So please prove this. And another thing, note that y has same property, that is y also lies between +1 to -1. Please check. This is another homework. And also comment on when y equal to +1, then A and B are completely associated and and y equal to -1 completely disassociated. So this is another homework. So please do all this thing and submit within a week. Okay. So I want to stop today class. So before ending my class, please tell me, have you any queries? So please tell me, have you any queries? Please tell me. So we'll meet again on Sunday, coming Sunday, same time, 6 p.m. Okay. So please tell me if you have any queries, and we'll continue this topic. Okay. So thank you. Thank you. Thank you, everybody. So we'll meet again on Sunday at same time, and we'll